Okay. So as I told you in the previous slides, I'm going to teach you how to use the calculator to end up or to calculate this MPR and NCR, MPR and NCR. Also, as I told you earlier, some of the universities or schools or institutes they are using the simple NPK and some are using NPR. Both are the same. Here, R or K is the number of arrangements required, the new arrangement, okay, or the number of selected characters, the number of selected objects. So you can call them R or K, it doesn't matter, okay, any of them. So both are the same. In Debrecen University, they are calling it K, but most of the world are calling it R. Even the calculator, they are calling it R. That's why you find it here, NPR. Okay, it is on the top of the X or the multiplication sign. Okay, so in order to get the yellow color on top of any of these signs, we have to click shift, which is also in yellow color, shift, and then the multiplication sign. If we want to get the NCR, also shift and the division sign. So here, for example, if I have NPR or NPK 7P3, okay, so we'll pick 3 out of 7. So here what we'll do, first we have to write this number on the calculator. So we have to click on 7, this is number 1, click on 7, and then you choose the MPR here, shift and multiplication sign. Okay, so shift and multiplication sign. Okay, then you'll click 3. So once you click here 7, it will write 7. Then when you click on shift and MPR, it will write P, and then you click on 3, it will write 3. When you click equals, you will get, when you go down and click enter, you will get the answer. The same thing here also here happens with NCR. So also you click 7C3, you click 7 first, and then you click shift and division, then 3, you'll get the answer. I think this is one of the most simplest way in case if you have your calculator is allowed in your exam. Okay, if you are doing it manually, don't forget that the factorials are not multiplied. So for example, if or a sum. So if I said factorial of 7 times factorial of 2, it doesn't mean factorial of 9. No, we have to expand. For factorials, we have to expand the factorial. Okay? Okay, I hope it's clear for factorials. And let us go to the summary of the counting. Counting principle. Actually, this is what we were studying from the beginning. We studied the permutation and combination, and this is called the counting. So counting, it could be permutation, it could be combination. This summary actually it helps 10% students, medical students, uh, to summarize and catch up any missing point, and also at the same time for other medical students or other students, if something which was not clear, maybe this flow chart will help them to catch it up. Okay, so the counting principle. We said the difference between permutation and the combination is order. The order matters or doesn't matter. If I have manager or I have deputy manager, I have secretary, I have chairman and deputy chairman, and I have secretary or I have co-captain in a team. Both of them are using the same, are occupying the same position. So the order matter or doesn't matter. In the case of there's an advantage like the manager and deputy manager and secretary or the chairman and chairman assistant and secretary. So here the order matters. In the other case, when we have two co-captain or giving $10 to each one, so the order doesn't matter who will get it first. Each one of the selected or the new arrangements will get the same thing, the same title, same position co-captain, or the same amount of money, $10. So order doesn't matter in this case. But if I have one boss and the other are assistant, or one manager, assistant manager, and secretary, so the order matters in this case. So the point here is order. The order matters or doesn't matter. So counting is the order matter. If the answer is yes, so we'll go to permutation. Straightforward. If the order doesn't matter, it's not important the order. There is no difference. There is no pauses. No different amount will be given here or there. So it is combination. This is just in summary what we'll discuss. Order matters, go to permutation. Order doesn't matter, go to combination. Okay. Then we have said that, okay, for permutation, if you remember, we have said that if I have n number, for example, let me bigger so it will appear. Okay, if I said n equals, for example, 7. If I'm going to use all the 7 characters, so this means that the number of ways to form this one, ni. Okay, if I'm using all of them, all the n's, the number of ways will be equal to ni, n factorial, n factorial. The number will be equal to n factorial. Okay, okay. Sorry, I'm calling it I, but it's in reality it is factorial, but I mean factorial. Okay, so if it is 7, it will be 7 factorial, 8, 8 factorial, and so on. This is in case of I'm using all the objects, all the characters, all the items which I have. Okay. Okay. We have also said that okay, if I'm using parts of the given object, not all of them. For example, I have 7 characters and I'm using 3 only out of them. So in this case, I'll have n, for example, equals 7 and k equals 3. So I have the general formula of permutation, which the number of ways will equal MPR 7P3 equals the number of ways will be equal either this or this. Okay, the number of ways will be equal n minus r in the denominator and on the top n factorial. Okay, so here will be equaling 7 factorial and here 7 minus 3 factorial. Okay, this is what we have already studied in the previous slide. Okay, you remember the example of math, the word math, which we have used in the example, and it has 4 digits, MATH, and we said, okay, the word math, if I'm using forming a new arrangement or new word out of the 4, I'm using all of them, so the number of ways will be 4 factorial. Okay, n equals 4, so n factorial equals 4 factorial. Okay, I hope it's clear. So this is a simple way. So here, if the order matters, we'll go to yes. Order matters, it will be permutation. Then we'll review all the permutation which we have. We have 4 cases for permutation. Okay, and we have 2 cases only for combination. Okay, in reality, in the previous slides, we have only studied 1 case for combination, but here there's 1 extra, and we are going also to emphasize on it here. Okay, so permutation, once we knew that order matters, it will be permutation. In permutation, I have to ask myself whether I'm using all the elements. For example, if n equals 7, I'm going to use the 7 or part of it, 4 or 3 or whatever. If I'm using all of them, all the elements, I have to go to yes. If I will not use all of them, then I will have k. In Debrecen University, they are calling K, or in some other universities, they are calling it R. So R or K doesn't matter. So I'll use it here K. Okay. So if I'm using all the elements, I will not have K. So in this case, if I'm using all the elements, N equals K. If you remember, I say NPR. NPR equals N factorial divided, sorry, in Debrecen we're using K. Okay, so NPK npk n factorial divided n minus k factorial. This is for permutation. You remember when we said that if k equals n, it will be n. So n minus n equals 0. 0 factorial equals 1. So it will be ni. This is the one which we said. This is the one which we said if you will use all of them, it will be equals n factorial. Okay? It will be equals n factorial. Okay. So, sorry, I'm repeating just to make sure that all the students are catching up and there is nothing unclear. Okay? So, again, here the order matter, it is permutation. If it is permutation, I have to check if I'm using all the elements. Yes, so here means n equals k. If I'm not using all the elements, the answer is no. So this means that I will have n and k, they're not equal. I will have both of them. So if I'm using the formula npk equals n factorial divided n minus k factorial. So in the first case here, I will have only ni. It will be, in this case, it will be n factorial only. Okay? Because here, n minus n equals 0. Okay, 0 factorial is 1. So n factorial divided 1 equals n factorial. So this is the case, which will be here. They are called permutation of all elements. I'm not picking 3 or 4 of, I'm using all of them. N equals k without repetition. There is no letters here repeated. You remember the example of Debrecen when we say that Debrecen has 3 E alphabetic letters within the word itself. So it doesn't matter which E comes first. So I have to deduct or to remove this E letters. And the example which we given for Mississippi and how many E's are there, how many P's are there, how many S's are there. You remember these examples? Okay, so here this is the word repetition. Repetition here means is any of the word are repeated or no. So here I'm going to talk about all the elements. Yes, so it will be ni. Okay, but sometimes I have all the words will be used, like the word math. The word math, all of them will be used, so it will be n factorial. But if I have another word like Debrecen, how many E's are here? I have 3 E's repeated. There is a repetition. If you remember, we said that we will have, in this case, we'll have n equals 1, 2, 3, 4, 5, 6, 7, 8. Debrecen, 8. And we have, how many will you choose out of them? We'll use all of them. We said all elements. All this branch are all elements. Okay? So I think this one should be here. So n equals 8. Okay? K equals 8 because we'll use all of them. We'll use all the elements. All this branch, yes, all the elements. But here we have a new factor which is R, repetition. Okay, which is 3. The E repeated 3 times. You remember this? When we say that, okay, it will not be ni in factorial in this case. It will be n factorial divided R factorial. Okay? I think better to remind you about it. Okay? I think we have used it for the previous slide for Mississippi. Yes, here. If we remember the example of Mississippi. Okay? And we said here we have the I letter repeated 4 times, and this letter repeated 3 times, and P letter repeated 2 times. So we say that it will be total number of Mississippi is 11, N equals 11. So this is NI 11 divided 4 factorial for the first repetition times 3 factorial for the second repetition times 2 factorial for the third repetition. Okay, so this is the same thing which is happening here. If I have similar case like Debrecen, it will be Debrecen, it will be 8 factorial divided 3 factorial. Okay, and if I have more repetition like Mississippi, it will be multiplied 2 factorial, 1 factorial, 4 factorial, whatever, depends on the number of repetition. So here we'll have n factorial, okay, divided the repetition. I could have one repetition like in Debrecen. I have only the alphabetical letter E is the only repetition which I have, and also I could have some other repetition like Mississippi. Here we have many repetition. The S repeated, I repeated, P repeated, I repeated 4 times, S repeated 3 times, P repeated 2 times. So it will be 4 factorial times 3 factorial times 2 factorial and so on. Okay, so this is the case which we have here. So here we will have n factorial divided the repetition because there is a repetition. Okay, I hope it's clear now. Just to memorize it, we'll go to order matters, permutation, then whether we are selecting all the options, all the elements, all the arrangement, all the characters, yes. So if we are selecting all of them, it is not ni or n factorial as default. No, it is n factorial in case of there is no repetition. If there is repetition, yes, there is a repetition. If there is a repetition here, it will be n factorial divided the repetitions. Okay, which could be R1, R2, R3 factorials, each one R1 factorial, R2 factorial, R3, or K1 factorial, K2, K3, and so on. Okay, so before moving from these two elements, which is permutation, all elements with and without repetition, always when we don't have repetition, this is the easiest and simplest way. Okay, if there is no repetition, this is the standard or the typical way. Okay, so all these branches, okay, where repetition is no, repetition is no, repetition is no, you will find them the easiest way, the same one which we have studied. We say we are using all the elements by default, no repetition. The repetition is the exception. So all the elements we are using ni. We said if it is not all the elements, we have to use the general formula n factorial divided n minus k. N factorial divided n minus k. This is the general formula. And this was if we are using all the elements. Here we are not using all the elements. So these two cases are straightforward. Also for combination. You remember we said that for combination, if there is no repetition, it will be NCK. It will be NCK. Okay, or NCR. It depends on the university you are studying in. Which is NCK equals same as permutation n factorial divided n minus k factorial times k factorial. K factorial. Okay, so this nk. They sometimes the writing it as nk. If it's written like this, it is combination. Okay. So coming here, this is the standard form nk. This nk, which is this form. Okay. So these are the three standard forms which we have used. This is in case of we're using all the items. This is in case of we are selecting some of the items only, which is K, and here if it is a combination only. Okay. So what is the difficult part here? The difficult part here will be in case if we have repetition. Repetition is the difficult part. Okay. So if we have repetition here, as we said, it will be n factorial as it is, but divided the repetition. So n factorial divided ki, k1 factorial, k2 factorial, k3 factorial, and so on. All the repetition which we have. Like this example. I have 4 factorial, 3 factorial, 2 factorial in the denominator. Because we have the repetition of I, 4, repetition of S, 3, repetition of P, 2, and so on. Okay? So this is the first one. Okay? Always when it is yes, repetition is there, it will be difficult. Okay. The second one, we said that we are picking some of the items. So it will be the general formula, n factorial divided n minus k factorial. But in case of we are picking some of the item and also there is a repetition there. So in this case, it will not be this formula. It will be n of power k. N of power k. Within 2 minutes or 1 minute, I'm going to give you examples on this from Debrecen University books. The last case or the third case here, for combination, we said the combination we are selecting from some items. So we have n, this is our population, okay, or our domain, and you are choosing only k number of them. So it will be this formula, okay. But sometimes we are picking k number, but at the same time we have a repetition. Like for example, if we ask you to choose something, amino acid to form protein, for example, amino acid could be repeated in the protein itself more than once. Okay, so you are picking some of the population or some of the domain, and at the same time, the same element which you are picking, it might be repeated. So it will be in this case, instead of nk, you have to write it outside to check. For example, if I said here 7k3, okay, so 7 is n, k is 3. So in this case, it will be what? In this case, it will be 7, sorry, it will be 7 divided 7 minus 3 factorial 3 factorial. Okay, this is the general case of the combination. But in case of high repetition, it will not be written in this one. It will be written n plus k minus 1. So I have to write it in this case n plus k minus 1. So 7 plus 3 equals 10 minus 1 equals 9. It will be 7 c 3. Sorry. It will be 7 plus 3 equals 10 minus 1 equals 9. It will be 9. It will be 9c3. 9c3. Okay? It will not be 7. If there is a repetition, it will be 9c3. So I have to add to the end the number of repetition. How many times it is repeated? How many times it is repeated? Okay? And then I minus 1 from them. So when we take the examples, it will be, I think, more clear. So let us start with the simplest or easiest one, where we have no repetition, no duplication, no identical alphabetical letter or identical objects or identical parameters there. Okay, so it will be like, for example, if we have permutation and we're selecting all the objects, okay, and there is no repetition, nothing is repeated. So I'm selecting from all the objects and no letters are repeated, like the word math. there is no repetition, and I'm using all of them. So here, this is an example in how many ways 5 different colors, okay, marble can be arranged in row. I have 5 different color of marble can be arranged in a row. Okay, let us assume any colors, marble or whatever, gloves or whatever. So I have 5 colors here. 1, 2, 3, 4, 5. In how many ways I can arrange this this colors? Okay, okay. So if I want to put here, the order matters or it doesn't matter? It depends. If it matters, it is permutation. So in my case, the question itself is about permutation. So the order matters. So in the first marble or the first glove, which I'll choose, the first glove can take 5 chances. Will have 5 chances. So 5. Here, the first one will be 5. 1, 2, 3, 4, 5. Any one of the 5. Any one of these 5. Okay, can be chosen. If I choose one of them, I end up with 4. So the second chance will be 4. The second marble will be 4 because I already taken one. So if I say this one taken and this one taken, the second one. So for the third chance, I have only 3. 1, 1, 2, 3. So here it will be 3. So I end up here 2 and here 1. So what is the total number of ways that I can arrange them in a line? In a line, not in a circle. You remember? I told you in a line. You remember before we said if we have a team or a people who are sitting around a rectangular table, okay, it is different from if these people are sitting around a circular table. If they are sitting, if they are sitting around this table, okay, so it has a starting point. They can start from here and go one here. So we have start and end, and even all of them can sit in one line. So we'll have the first one and the last one. Okay, so you may end up with having first one, which is near to the post, second one, third one, fourth one, and so on. Okay, and fifth one in a line. But if they are sitting around circular table, if you remember, we said that this will be combination. Combination. Here it is permutation. Okay, so this gloves I want to arrange them in a line, not in a circle, in a line. Okay, so there will be it will be a permutation problem. He didn't tell me that he want to arrange them. He gave me already all 5 colored marble only, and he asked me to arrange them. Okay, okay, okay. Sorry. So here I have the first marble. I have the second one. I have the third one. I have the fourth one, and I have the fifth one. Okay, so I have 5 marble. If I use one of them, no repetition. It is only one from each color. It is only one. If I use this color, it's only one. If I use this one, it's only one. It's only one from each color. Okay. So it is permutation problem. So the number of ways I'll have 5 factorial, because it is 5 times 4 times 3 times 2 times 1. This is the 5 factor. It will be 5 factor. So if I have 7 number, it will be 7 factorial. Okay, if n equals 9, it will be 9 factorial, and so on. I have 5 here, it will be 5 factorial. N factorial equals 5 factorial equals 120. So I have 120 number of ways to arrange this marble in a line. Okay. Okay. So again, just to clear this question. So here we have there are 5 different objects will be arranged with regard to the order. So here it is permutation without repetition. Okay, of the 5 objects will be taken. So the first position can be occupied by 5 marble. Any one of the 5 marble can occupy the first position. The second position would be by in 4 ways. Could be the rest of the 4. Here, the third position would be the 3. The second and the first and so on. So the first one will have 5 opportunity, 5 chances, and for each one of them, if the rest of the 4 are the same, so we'll have 5 chances. But I have the first one will have 5 chances. Okay, we'll have 5 chances, but also the second one also will have 4 chances. The third one will have 3 chances. The fourth one will have 2 chances. The last one will have 1 chance, and so on. So it will be the multiplication of them. It will be 5 times 4 times 3 times 2 times 1, which equals 5 factorial equals 120. Okay, I think this one is clear. Okay, so this is the first one. We are done with it. The second one also, let us take we are done with the permutation of all the numbers without any repetition. So let us take also the combination for all the number without repetition, which will be this one. So per combination, there is no repetition, okay, and we are using the combination, and there is no repetition, and of course for combination we cannot use all of them, otherwise it will not be different combination. Okay, so it's in k, so it will be this formula. Okay, so it will be n factorial n minus k factorial times k factorial. So here, if we look at this example, a researcher would like to test 4 drugs. So this is k for n, the total number. Oh, this is the total number for drugs. So 4 drugs will be n. N equals 4. But the number of experimental animal is only sufficient to test 3 of the drugs. So K 3. Does it matter which animal will be tested with which one? No. So in how many ways can the 3 drugs be selected? Okay. Okay. So here there are 3 drugs to be chosen. You remember we say that combination we call it chosen. So it is n equals 4, k equals 3. It will be 4 C3. It will be 3 drugs to be chosen from 4. Okay. Okay. So the question here, there are 3 drugs to be chosen from from 4 ones. Okay. 3 drugs will be chosen from 4 ones without regard to the order. The order doesn't matter which one comes first. So it is a combination. If it is without regard to the option or to the order doesn't matter, it is a combination problem. Without repetition, because if I repeated them, it will be 5 drags or 10 drags or 7 drags. So it is without repetition. Okay? So it will be the traditional or the normal or the general law for combination. So it will be NCK equals n factorial divided n minus k factorial times k factorial. So it will be n factorial means 4 factorial divided n minus k which is 4 minus 3. 1 factorial. Okay, and then times k factorial, which is 3 factorial. Okay, so it will be 4 factorial can be expanded into 4 times 3 times 2, and here 1 factorial, we ignore it, and the 3 factorial. Okay, so 3 factorial can be calculated on the calculator itself, or what we can do, so we can expand it and cancel it. Okay, just let me answer this one with you. So the problem here will be n equals 4, k equals 3. It will be n c k equals 4 c 3 equals 4 factorial. First one, this minus this, 4 minus 3 factorial times the last one, 3 factorial equals 4 factorial divided 1 factorial, 3 factorial. Okay, so 1 factorial will be cancelled. So it is 4 factorial divided 3 factorial. 4 factorial can be expanded 4 times 3 times 2 times 1, which is 3 factorial. Okay, divided 3 factorial. So this one will be cancelled with this one. So we'll end up with 4. Okay, so the answer will be 4. Okay, this is the second one. The example for the, so we are done with this one, and also we are done with this. Okay, so we said that if we are using all the elements and there's no repetition, it will be the most easiest one. Okay, here we are done with the first one, all the element, and no done with it. Here repetition, and we have used without repetition, so there is no repetition. Okay, but we are taking only sample of the full domain, which sample is k, not the full number. Okay, if you notice here, we have all the elements, but here we don't have, it is only repetition. Okay, okay, that's why the number of options here is 4, 1 2 3 4, and number of options here is 2 only, because here there is all element and then repetition, but here we jump directly to repetition, combination repetition directly. Okay, okay, so coming to the next example, which also is no, there is no repetition. So we started with all the easiest one, no repetition, and no repetition. So here, if I have the general case, I'm not using all of them. I'm just picking a k number, but there is no repetition. So here, all the elements, no, it is not. I have n and k, but there is no repetition. No, like no Debrecen, no Mississippi. Okay, so it will be the general form n factorial divided n minus k factorial. If you want to see an example here, this is the example. In how many ways, how many different arrangements, he's talking about that, can 10 people be seated on a bench? On a bench, what is this bench? Bench, circular bench? No, bench is longitudinal bench. It's not a circular table. Circular table, it will be combination. But here it is permutation, okay, because it is on a bench. So it differs who will sit first, who will sit second, and who will sit third. Okay, who will be nearest to the board and the professor, okay, and who will be far from it, okay. So it is a permutation on a bench. If four seats, if only four seats are available, so let us identify the total number of people are 10, which is n, and k is 4. So let us write here n equals 10, k equals 4. It is permutation? Yes, it is permutation. So it is 10 p4. Okay, n p k again. Okay, so mpk, if you remember, it was in the general case, if we have k and we have n, it will be the first one in factorial divided n minus k factorial. Okay, there is no times k here because this is permutation. This is not combination, so there is no k here. Okay, this is the only difference between permutation and the combination. Okay, so what will be the answer here? The answer will be 10 factorial divided 10 minus 4 factorial. 10 factorial divided 6 factorial. I can expand it. So I will 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. No need to have all these things because from 6 up to here, it can be written as 6 factorial, right? So I can delete all this up to here and write 6 factorial, okay? And I haven't done 6 factorial. I just reached it. If I reach the 6 factorial, I have to stop. So I can cancel this with this, okay? So I end up with 10 times 9 times 8 times 7, which equals 5040. Okay, clear? I hope it's clear. So now we are done also with the third example. So coming here to the permutation with the repetition, like Debrecen, like Mississippi. It is the same way, but just we'll divide by decade. So here, if you go to page 26, let us see. Okay, because it is biostatistics, so most of the examples here are related to the biology. So it is mentioned here in how many 5 amino acids, okay, oligopeptides can be structured from the following amino acids. N and C termini can be differentiated. Okay, so we have here two what? Two lysines, two valines, and two leucine. Okay, one leucine. So two lysine, two valines, and one leucine. Okay, I have two, one, and one. Okay, okay. So if you remember the example that we have given here for Mississippi, the word Mississippi. Okay, I have I repeated 4 times, S repeated 3 times, and P repeated 2 times. How I know that? I counted the I here. I count 1, 2, 3, 4. P 1, 2. S 1, 2, 3, and I wrote them down. But in our example here, they have given us the repetition. Okay, so we have the total amino acids which is available 20, but doesn't matter. He said how many 5 amino acids, okay, oligopeptide can be structured from the following amino acids. Okay, so he's going to use all of them, all the 5 amino acids, okay? But there is a repetition. This lysine and valine are repeated. So how I can answer this one? I can write N equals 5 amino acids. Okay. What is the repetition? I have here K1 or R1 or whatever. K1, which is 2. This is the sign. I have K2 equals 2, which is the line. I have K3 equals 1. This sign. This is how the 5 amino acids oligopeptide are. Okay. 2 plus 2 plus 1 equals 5. This is the breakdown of the 5. Okay, how the 5 are distributed. The same concept of the Mississippi mechanism. So here is it permutation or combination, of course, in all on all proteins. Okay, which is using amino acid, the order differs because if the order of the amino acid change, the protein name will change. So all the amino acids by default it will be permutation. Do we have repetition? Yes. If we don't have repetition and we are using all of them, yes, here we are using all of them. So it will be n factorial. But here because we have repetition, it has to be divided by K1 I, K2 I factorial, K3 factorial, and so on. Okay? Or R1 factorial, R2 factorial, R3 factorial. It depends. You can write it any way you want. Okay? So not to confuse. So R1 factor, R2 factor, R3 factor. So it could be this one or this one. Okay, in one of them. So it will be n factorial 5 factorial divided K1 factorial 2 factorial, K2 factorial 2 also factorial, K3 factorial 1 factorial. Here he did not write it because 1 factorial doesn't mean anything, it is 1. Multiplied by anything, it will be 1. So equals, it will be 5 times 4. I'll keep expanding it until I reach the biggest factorial here. These two are the same. So in one of them, times the 3 times 2 factorial. Okay? And here 2 factorial times 2 factorial. And 1, we can ignore it. 1 factorial can be ignored. Okay? So one of these 2 factorial will cancel with this 2 factorial. 2 factorial is 2 also. So 2 can be cancelled with this one to give us 2. 5 times 2 equals 10 times 3 equals 30. Okay, so the answer is 30. I hope it is clear. Okay? So this was the first one of the repetition which we have, which is the simplest one and which we have already taken either for Debrecen and for Mississippi. But now coming to the repetition, and we are using partially. Okay, so what will be, so here we are not using all the elements, we're using part of it. Okay, but in the case of the amino acid we were using all of them. Okay, we're using all of them, all the elements, yes, we use all of them, all the 5 amino acids we're using them. But here we'll take one example now where we are not using all of them and there is a repetition. So it will be n of power k. Very simple, but actually sometimes we mix between this repetition here and the repetition here. The difference that here we are using all the elements given, not all the elements in the world, all the domain which we have. The domain which we have for the last example for the amino acid is the 5 amino acid. This is everything. We use 2 of them here and 2 here and 1 there, but the domain is the 5. We're using all of them. Okay, the total number of amino acids which we have in the world is 20 amino acids. So if we are using all the 20 amino acids, in other examples, if we talk in general about the amino acids and we are using all of them, so it is all the elements. In the previous example, we have used only five, but it was all the element. Why? Because he was talking only about five. Our domain was five, limited to five. But in the incoming example, our domain will be all the amino acids, will be the 20. If we are using all of them, it will be this row. If we're not using all of them, it will be this row. Okay? So here we are not using all the elements and there is a repetition. Because amino acid, it has two principles, two things you have to keep in mind. Amino acid, which is forming protein, always it will be permutation because the order of the amino acid it matters. It changes the type of protein which is formed. Okay, so and repetition is there. So always amino acid it can have repetition and amino acid also at the same time. Uh, what we have said is that we have said that the amino acid it can be repeated and it will be permutation. Okay, okay. So here it has repetition and we'll use all the elements. Okay, so let us go through this example, page 24. Okay. How many oligopeptides containing 5 amino acids can be formed? So here he is asking us about how many oligopeptide containing 5 amino acids. So this is the K. This is the outcome, the product containing five. In the previous example, the given, okay, in the previous example, here, where is the previous example? Yes, in this example, which we have taken, the previous one, the domain was the 5 amino acids. This is the given, the total number five, and this is the breakdown of them. The repeat, how many each of them repeated. Okay, but in this example, he wants us to tell him how many oligopeptide containing five. The containing, this is the product, this is the new arrangement, this is the K. So here K is 5 amino acids. So what is the N? Out of how many I can form this amino acid, okay? Oligopeptide containing 5 amino acids. Out of how many amino acids? I don't know. He didn't give it to me, but I know that the amino acid in the world it is 20. So 20 amino acid is N. This is the total number of available amino acids, and he want to form oligopeptide containing 5 amino acids only. So out of 20, you want to choose 5. Okay? So we have to be careful which one is the domain and which one is the K, the selected or the new arrangement. So here, the new arrangement which he wants, it should contain 5 amino acids. So this is the K. In the previous example, he was asking how many 5 amino acid oligopeptides can be constructed from the following amino acid, and he gave us this 2, 1, and 1. So 5, total 5. This is the domain, and this is the breakdown of the domain. Okay, so here we have n equal 20 and k equal 5. But when we look at it, it is, of course, it is amino acids, so it will be permutation. We are using all the number or no, we don't know. Does the order matter? Of course, the order of the amino acid matters. Okay, is repetition is allowed? Of course, it's amino acid, so repetition is allowed. So it will be permutation and repetition is allowed. But we are not using all of them. So this is the difference between this one and the previous example. So here we have 20, and we have to form oligopeptide of 5 amino acids. In the previous example, it was 5, and we have to form using the 5. So N and K were the same, all the elements. So 2 plus 2 plus 1 equals 5. And here 5. So we're using all of them. But here, the total number of amino acids in the world which we have is 20, but we are using 5 only. Okay? So it will be N of power K. N of power K equals 20 of power 5. And on the calculator, you can get it. Okay? So we are also done with this one. So the last one, which is combination, and there is repetition. Always when we take combination, we take without repetition. Combination, and we use this law. Okay, but now we'll have combination with repetition. If we have a repetition, as I told you, instead of having 7C3, it will be 7 plus 3 equals 10 minus 1. So 9C3. Okay, if there is a repetition. If there is a repetition. Okay, so in this case, this one will be the repetition. The 3 will not be the number of selected objects. It will be the number of repeated objects. Okay, and it will be clear for us in the when we come to slide number 29 or 28. Okay. So here, the telephone in a family consisting 4 person rang twice. Okay, a telephone in a family consisting of a 4 person. So this is a family consisting of 4 persons, and this telephone rang twice. Okay, so there is a repetition or no? Yes, there is a repetition. It rang twice. The total number of people are 4 people. Determine in how many different ways the members of the family could pick the phone without regard to the order. So he told me here it is combination without regard to the order. So the order doesn't matter. Ahmad pick it first or Sam pick it first. So it doesn't matter. Okay? Who pick it first? Without regard to the order. So it is a combination problem. Combination, and there is a repetition. Yes, it ranks twice and 4%. So n equals 4. Repetition k equals 2. So it will be, in traditional way, it will be ncr. It will, or nck. Okay. It will be 4ck, but this is not the right thing because we are in the case of repetition. It will not be 4c2. It will not be 4c2 because we are in a repetition case. So it will be 4 plus 2 equals 6 minus 1 equals 5. So it will be 5c2. Okay, and we have to ignore that. Just I'm writing it to show the way how to calculate it. So 4 plus 2 minus 1. 5, because there is a repetition in this case. Okay, so how it will be? It will be, we'll take this one here, numerator 5 factorial divided 5 minus 2, 5 minus 2 factorial, 2 factorial, traditional way of answering any combination problem. So it will be 5 factorial divided 3 factorial, 2 factorial. I'll choose the biggest one and I'll expand this one until we reach to it. So it will be 5 times 4 times 3 factorial, and yes, 3 factorial, 2 factorial, 3 factorial with 3 factorial, 2 factorial means 2. 2 will be cancelled with 4 and will give us 2. So we end up with 10. Okay? I hope it is clear also. So by reaching this point, I hope that all of us understood the counting, permutation, combination, and how to differentiate between them, how to answer the problem, how we can understand and digest how they can be classified in case of we are using all the elements. We'll have only one case and the general formula if there is a repetition. Okay, and if we are picking some of the elements only, not all of the elements, we'll have the general formula for all permutation which can or permutation which can be used for any type of permutation. And also we have this special case when we are not using all the elements and at the same time we have repetition which is n of power k, and the same thing for combination, and we have to remember the combination law. And also if we have combination with repetition, okay, how we know combination, the order doesn't matter, and the combination it will be mentioned in the question itself. So by having this point, I hope that we already done with permutation and the combination, and wish you all the best on your exams. And thank you, and we'll meet in the next topic.